Good morning, everyone. Happy Monday. Hope you had a wonderful weekend. Hope you enjoyed again, it's a nice day. It rained yesterday, but it was still pretty nice. So I hope you had a good time. We are going to start here in just a second. First of all, I do want to point out we have 2 weeks left. So these next 2 weeks are the last 2 weeks of new material. So 1 week, Friday quiz, then the next week we do another week of material, and then we're done. The May 18th and 19th. May 18th is awesome because it's my birthday. May 18th and 19th are kind of catch-up days, just making sure that we take care of anything we need to take care of. And making sure you get caught up with anything. But then after that, the 20th is the last day, and we really aren't going to do much of anything after next Friday. What day is that? Friday the 15th. Okay, so Friday the 15th is pretty much the last day of new material. Just wanted to give you that heads up. Okay, I hope you enjoyed the video. And they really are awesome, and they do some really cool things. And yeah, I enjoy watching their videos. Let's get started. So for today, I do need you to have your homework for 932 if possible. So if you can, look back through problem 9, homework 932 before we proceed with this video. Cool? All right, let's begin. Well, system of inequalities. So we are moving on now to section 9.4, how can I represent it? And we're going to focus on system of inequalities. We've done system equations, we've done inequalities, putting those together. The cool news is that it's not a lot of new stuff. It really is kind of bringing back everything we've done up to this point. If you have not done your quizzes, most of you did great job taking pictures of it and sharing with me. It was pretty easy to do and grade and check. If you have not done it, please make sure you do that. Okay, let's go for here. In chapter 4, you learned that the solution to a system of equations is a point that makes both equations true. But what about a solution to a system of two inequalities? How can you represent these solutions on a graph? How many solutions can a system of inequalities have? Consider these questions as you learn how to graph systems of inequalities. And again, please have your 932 day 1 homework out. Cool? All right. First problem, look at the graphs of your problem 984. That's a 932 homework. Problem 984 for y is less than or equal to negative x plus 5 and y is greater than 2/3 x minus 1. So at this moment, if you don't have it already, please pause the video, find that homework, problem 984, and check out those graphs, okay? Okay, hopefully you got them. If not, here's what they look like, okay? So this one's y is less than or equal to negative x plus 5, and this one's y is greater than 2/3 x minus 1, okay? Makes sense. Look at those two graphs, separate. These are all the answers to that one. These are all the answers to that one. Well, what would the graph of the system of inequalities look like? Which points are solutions to this system? That is, which points make both of those inequalities true? And so what I want you to do is I want you to, on a separate piece of graph paper, I'd like you to graph both of those inequalities. Now we're going to actually do this one together because I really think it's powerful and you need to try this out, okay? So please make sure you do this with me. Set up a coordinate grid right now, I went to 5 to negative 5 in both sides. You can go a little bit bigger than that if you want to, but pause the video if you need to. Bring up that just a 5x5 grid and let's do it with it, okay? So the first one, negative x plus 5. So I know the y-intercept is 5 and the slope is negative 1. So it would just go like this, okay? So that one's pretty straightforward. Just goes like that. And it does have an equal sign, so it's going to be a solid line, okay? Cool. Now, don't worry about the shading right now. Just go ahead and focus on that point right there. The next one, and I'm going to go with a different color for this one. And again, this is basically what you had before, so it should be kind of transferring that information onto your graph. 2/3 x minus 1. So that means the y-intercept is negative 1. And then it goes a rise of 2 and a run of 3. So rise of 2, run of 3 would be a point right there. Rise of 2, run of 3 would be over here somewhere. And if I go backwards, 1, 2, 3, 1, 2, cool. Now, this one does not have an equal sign, so it's going to be a dashed line on those points, going all the way up, okay? Don't forget the arrows at the end. Now, how do you think we proceed from here? Here's how I want you to proceed. we are going to do some shading. Now, the shading is a tricky part. Now, we know that for the red line, we're looking for a point that is less, well, y is less than, this one's red, y is less than or equal to negative x plus 5. So if I plug in 0, 0, I get 0 is less than or equal to the opposite of 0, which is 0 plus 5. So plus 5, is 0 less than or equal to 5? Yes, it is. So everything to the left of this red line would make that inequality true. Now, here's a thing to watch out for. If you shade in really solid, it's going to cause a problem, isn't it? Okay, so maybe wait until you see what's going on before you do any shading, okay? But I want to show you how to do it. Then to the second one, the blue one, we have y is greater than 2/3 x minus 1. Well, that one, if I plug in 0.00, I get 0 equals 2/3 times 0, 0 minus 1. Is 0 greater than 1? Negative 1, I'm sorry, negative 1, and yes, it is. So therefore, 0.00 works. So everything above this line is going to get shaded in. Okay? Now, what area makes both inequalities true? And the truth is, the only area that makes both inequalities true is this area where we double shaded. Now, what you are going to do is you have a couple options. You could do designs, but you see how sloppy it gets. The best option is when you are shading the red, shade all of this red part, but shade it lightly. Don't go really heavy, just shade it lightly. And when you're shading the blue part, do the same thing. Don't shade it too heavy, shade it lightly. And then once you see, excuse me just a second, excuse me, sorry about that. Once you see the area that's shaded for both, then go back and shade this area even darker. And that would make that inequality then work for that. Cool? That's how you would know the answer. Now, bottom part right here. If you have not done so already, verify your solution to the region from part A algebraically by substituting the coordinates of a point from your solution region into the inequality. Now, please note, it says into each inequality. You do have to plug a point from that region into both of them. You cannot do just one, because if you do just one, it just verifies that it works for one, not for the other. And trust me, I've had kids who do this work and then shade like the blue on the opposite side, and then they test a point on the red and they verify the blue, and it goes wrong, and they're all wrong, but they don't know because they were a little lazy with that work. So please plug it into both. Now, since you see 0.00, 0.00 works for both of them, we're going to go ahead and go with 0, 0, and that makes this one true, and it makes this one true. So therefore, we are correct. We are good to go. Cool? All right. Well, now it's your turn. So, and this is the only other problem we're doing today, okay? Draw and graph the region satisfying both constraints below. Start by graphing the boundary lines, and then test the points to find the region that makes both inequalities true. Go. So I want you to pause it. I would like you to try the whole thing without me. And then when you're done, unpause it, and I will go through it with you. Okay. All right, here we go. Let's go for the first one. Y is less than x plus 2. Y-intercept is 2. And then x, that means the slope is 1. So that means it's going to go right here. Oh, that's nice and easy. Okay. It is less than, not less than and equal to, so therefore I need a dashed line along this line all the way down, dashed line, arrows at the end. Perfect. Ta-da. Okay, now the next one, and I'm going to do a different color. Let's go with purple. Okay, cool. Purple. Y is less than or equal to 10. Okay, 10 is a y-intercept. Minus 3/4 x. So that's a slope of -3, rise of -3, run of 4, 1, 2, 3, 4. Rise of -3, 1, 2, 3, 1, 2, 3, 4. Can I go one more? No, I can't. Now this one does have an equal sign. Is greater than or less than or equal to, so it's going to be a solid line all the way down. Put my arrows. Ta-da. Okay, now I need to verify. So if I plugged in 0.00 into, let's go with the second one because I've got the purple pen. 0 is less than or equal to 10 minus 2/3, 3/4 times 0, 0. Is 0 less than or equal to 10? Yes, it is. So therefore, everything below here gets shaded. Now, let's try the other one. Is 0 less than 0 plus 2? 0 plus 2 is 2. Is 0 less than 2? Yes, it is. Therefore, everything down here works. Now, be careful. What region makes both inequalities true and should be shaded darker? It should be this whole region right here, because, green and purple make red, right? All right, yeah. Now, it goes all the way up to here. Please do not confuse it with your x and y axes. It goes all the way to the graph, okay? Now, again, okay, I don't like this. Technically, we should have done something maybe greater than, so that it was one of these. It could, because guys, it could have been this section up here, or it could have been this section up here, or it could have been the section over here. We have been fortunate that in both of our cases, 0.00 works. Otherwise, you would have to plug in another point that would work. Now, what would be easy? Well, 1, 1, or 2, 2, or 5, 5, or something simple like that. Easy numbers to work with, or -5, -5. But think about how you might prove that. Be careful with your shading. Again, do one side light, and where it double crosses, go dark in that area there. Cool? All right, well, ladies and gentlemen, your homework is problem 94 to 96, so 94, 95, 96. Do that, and good luck. I will talk to you guys tomorrow. We'll finish this lesson tomorrow, okay? All right, see you later.